Hello, I'm Neeraj. Today I will try to explain that why we are using the concept of L2-Norm and unit sphere in the case of contrastive learning and self-supervised learning. Actually, what happens, L2-Norms helps us in normalizing the data so that we can put all the data on the surface of a unit sphere. But before going into the detail, first of all, we will go through one by one. So what is L2-Norm? So instead of going lot of theories, I will just explain that how we can get the L2-Norm. Suppose we have a data like this. So to get the L2-Norm, we will take the square root of sum of all the numbers squares. So it will be equal to like square root of 1 square plus 2 square plus 3 square. It will be equal to square root of 14 and it will be around 3.74. So now to compute the L2-Norm of 1, we will just use 1 divided by 3.74. I have calculated this number is equal to 0.267. Similarly for 2 we can compute it like this. It is equal to 0.534. Similarly for 3, norm will be equal to 3 divided by 3.74 and the value will be equal to 0.802. So this is the way to compute the L2-Norm. So you can see the values here after L2-Norm computation. Similarly, you can say that how we can compute the L2-Norm if we have data into multiple dimensions like 3 dimension. So here it is again very simple, just to compute square root of sum of square, all squares till 9 square. So I have computed it. It is equal to 153 and it will be equal to 39.12. So we can easily compute the L2-Norm of 1 divided by 39.12 like that. So this is the way we can represent those numbers through L2-Norm. Now what is the benefit of L2-Norm? So once we convert the data into L2-Norm, we will be able to represent those data on the surface of the sphere, surface of the unit sphere. So unit sphere and L2-Norm both are connected to each other. So unit sphere is the sphere which contains set of points where the distance from the origin or center, L2 or Euclidean distance from the center is always equal to 1. You will say that how it is different from unit ball kind of thing. So in unit ball, the L2 distance from the center may be less than or equal to 1. So this is the different. Now you will say that now what is the benefit of such kind of representation? So generally, suppose you are going to apply contrastive learnings by taking some images of cat and some images of dog and having different contrasts. So due to different contrasts or maybe different color depth or etc., you will get different skills, and due to those different skills, when you try to learn the comparisons for contrastive or in learning or in contrastive representation learning or similarity based representation learning, dissimilarity based representation learning, the system will also start focusing on the scales, the numerical scales like numbers or distances. They started learning those kind of points things, and due to which you will get poor accuracy. So a very simple example, just to take your MNIST data. This is a very simple character, handwritten character data. Take some set of character, color it through some particular color. Suppose it is a red color, and for other, just color it to some different colors. You have a 20% red color images for a particular set of numbers or particular set of characters. So after training, you will find that if you take some another number from test data and color it red, then your trained system shows false predictions, and they said they will assign some of the red color number for your number. This is because you have a multiple red color numbers and system got biased towards that. And so to avoid the chances of such kind of biasness due to different scale levels, we prefer to use the L2-Norm and unit sphere. This property, the unit sphere actually supports the property which is called scale invariance. So due to this property, the entire whatever will be the data after conversion, all the points will be on the surface of the sphere. So for example, in the case of cat and dog, so suppose your cat will be, points related to cats will be here, and the dog having some dissimilarity, so maybe it will have some points here. So you can easily see the distances. So after that, the system can concentrate on features. This is the main reason people use unit concept of unit sphere and L2-Norm in the case of self-supervised or contrastive learnings. Now, from the property of sphere, you can easily understand that if we increase the distance, the angle will also change. Other thing is, why scale invariance property unit sphere supports? Because when you take this small angle only, if you increase it, you can see that how big area it is covering. So for that, all those scaling high scale points, it project on this part. That's why unit sphere is able to project a huge number of points on those surface of the sphere. And due to this scale invariance property, the system will be less prone to overfitting. Means it will not go for overfitting frequently, or it will be, means chances will be reduced for overfitting also. The system will be stable in the case of training also.